Okay, so all of you are standing someplace. Point in the direction that would be hardest for you to walk, right? The most uphill direction from where you are. Okay, some of you are confused, right? Because you're standing on top of something or in the bottom, right? You guys see that? So for Mark and Donald that are standing on the tops of something, why don't they have a gradient? Why can't they point at a steeper spot? Yeah, one, there's nowhere to go, and two, in terms of the derivatives, yeah, both components are zeros, right? You guys see that? So from where they're standing, they are pointing in the direction of greatest increase, right? It's the zero vector. Same with bottom of a hole, right? But like Kaz, he has a reasonable direction that he could go to go uphill, right? Kind of pointing at the maximum. Is anybody else not? Oh. Ryder's not standing in a hole or on a peak. Where's your gradient vector? Okay, so that's the highest spot near you, right? Okay, so if you move along the gradient vector a little bit, right, you're going to end up at the top of something. Yeah, or definitely uphill from where you were. You guys see that? So is there a spot in here that you could start that you wouldn't necessarily end up on top of something fairly quick? Oh, that's good. So what's your gradient vector?
Maybe up here. Or behind. Or, well, it depends. Well, that slope's less, but if we
Which one's steeper?
The same. This one looks steeper.
Okay, so if you're standing in the very bottom of that saddle, what's your derivative in both directions? Zero, right? So does he have a gradient vector to point at? No, it's the zero vector. But if you're a little bit offside, right?
Yeah.
Then there's definitely a steepest way. The moral of the story for saddle points, right, is that this jazz has to be a function, right? So that it has to be one unique direction that's most uphill, right? If you're standing in a saddle, you've got two directions that are most uphill, right? And so if you don't return a zero vector information, you're not a function anymore, right?
So Sarah could make some steps.
Yeah, so Sarah's, are you in the bottom of that hole or are you a little off to the side?
Kind of in the bottom.
Okay, so if she's in the bottom, where's her gradient vector?
There is no gradient.
The gradient vector is zero, right? There's not a useful one. So
it's called zero even if you're at the top of the hill.
yeah, so it's a zero vector if you're at the top of the hill or the bottom or sitting at a saddle,
Okay.
right? Which tells you that if you start in one of those spots with one of these optimization processes, you're going to stay there.
Will the sharp point still be zero?
So a sharp point maybe wouldn't be differentiable, right?
Yeah.
What would a point of differentiability or non-differentiability do to our definition?
It's not defined in...
Perfect. It's not defined, right? Because one of the components of my vector doesn't make any sense. Cool?